On 23rd of August 2013, a fire broke out in HPCL Vizag refinery's cooling tower at around 4 pm. The fire was brought under control in 45 minutes. The accident caused as many as 29 fatalities, while many others sustained varying degrees of burn injuries. 10 months before the incident, two cooling tower cells collapsed. As a result, the common distribution header was balanced on third and fourth cells. 6 months after the initial collapse, the remaining two cells also collapsed. The reason for the collapse was the uneven distribution of the headers and the poor quality of wooden fills. While the renovation was going on, a fifth cell was also being commissioned with interconnections and jumpovers. In order to sustain plant operations, it was decided to use the fifth cell while the work was going on to renovate the other four cells. A tie-in connection between the return header was to be used for this purpose. On the day of the accident, the commissioning of the tie-in connection was completed at around 4 pm. The project team decided to go ahead with the opening of the tie-in connection. Unknown to the plant officials, hydrocarbon had leaked into the cooling water line during a previous incident and had accumulated in the pipeline. As soon as the valve was opened, these hydrocarbon trapped in the pipeline found an exit. They reached the fifth cooling cell where a vapor cloud of flammable hydrocarbons began to be formed. At this time, many hot jobs were being carried out in the vicinity as work was going on to renovate the other cells. As soon as vapor cloud came in contact with the hot job, the vapor cloud exploded, setting the entire cooling tower on fire. 29 lives were lost and many people suffered various burn injuries from this fire. The major reason for the blast was flammable hydrocarbons which had leaked from the process units and unknown to plant personnel were present in the closed return header. Installation of gas detectors would have prevented such a catastrophe at the first place. At the time of opening of tie-in connection, the header and riser pipes were undergoing repairs. Investigation revealed at the time of the incident, a total of 16 hot jobs were going on. The process of stopping all hot work before commissioning of any new system or facility was not adhered to. While commissioning activity is undertaken, it must be ensured that other than the minimum number of required operating crew, nobody should be allowed to be present at the work site. Lack of proper housekeeping at the commissioning site also contributed to the large scale of the disaster. Unwanted wooden debris material should have been cleared out at the hot job site. Finally, the original cooling cell collapsed because of lack of proper quality check and enforcement while procuring the wooden fills. The wood used for the fills was of poor quality, which led to the collapse of the cells.